lessons that follow each other, like 89, 90, 91, 92, or whatever it is?
Possibly. Do we actually have that happening this time?
Yeah, these four are together, and then it breaks up again.
Yeah. Okay. We are in lesson 90, and we are talking about particle motion. Okay. Now, when we talk about particle motion, and this is particle motion 2, which, is just saying that we've talked about it before, before this point. But the comment I put here, okay, when we talk about the integral of velocity, right? We know the integral of velocity is the position, or, the position of the particle is what we usually say. Okay, so the definite integral of the velocity function of a particle moving along the x-axis represents the algebraic sum. So how far left, which of course are negatives, and how far right, which are positive, those distances put together traveled by that particle. So that integral is representing the total sum. Okay? And as I said, you have to keep in mind that negatives are left. And so overall, it's going to end up representing, we talk about how, does the position of a particle change? It's going to end up representing the net change. Like, where is it in relation to where it began, essentially? Okay? So, if you're trying to read that, it says the definite integral of the velocity function of a particle moving along the x-axis represents the algebraic sum of left and right distances traveled by the particle. Where left, of course, is negative, and right is positive. Now, as we look at example 1 here, the velocity function for a particle moving along the x-axis is v of t. The following is given. So the integral of v of t, and that does say, I don't know if you guys can read that or not, from 1 to 2 is negative 7. The integral from 2 to 3 of v of t is 3. The integral from 3 to 4 of v of t is negative 2. And the integral from 4 to 5 of v of t is 6. So those are representing the integral of the velocity. How much does the position of the particle change over the interval from 1 to 5? So thoughts on what we do here? Add them all up? Essentially right. Okay. If this is, we're starting at 1, right? What's our first interval we know? From 1 to 2, there is a change of what? Negative 7. What does that negative 7 indicate? That would be left 7. Okay, so that's from 1 to 2. Then what happens at 2? From 2 to 3, we're going to go what?
Right.
It's a positive 3. So right 3. And then after 3, we can go 3 to 4. And from 3 to 4, we're going to go negative 2. So left 2. And then from 4 to 5, there's a positive 6 change, so we're going right 6. Okay, so left 7, then back 3 right, puts us still 4 left of where we started. Minus 2 left takes us 2 left back again. And then 6 right takes us to 0. So how does the position of the particle change over the interval? Well, 0 means that there is a net change, if you would. A net change of 0. So they moved left, they moved right, but they ended up where they started. Okay? Let me know if you have questions. If the particle is at x equals 7 when t equals 2, what is the position of the particle when t equals 4? So what interval are we looking at here? We're starting at t equals 2 and ending at t equals 4. So we are essentially just focused on the interval from 2 to 4. What's the other important piece we have to keep in mind, though? Yeah, we're starting at 7. So you're not just starting at a neutral time 0, you're starting at 7. So if we start at 7, and then, so at time 2, what's the first thing we are going to do? From 2 to 3, we're going to go right 3. So we're going to add 3. That's from 2 to 3, and then what? From 3 to 4, it's a negative 2, so we're going left 2. And then what? We're done? Because we want to know what is the position of the particle when t equals 4. So if you start at 7, you go right 3, and then left 2, where do we end up? 8. At 8.
I can add and subtract.
You know, being able to add and subtract is a good thing. We joke about it, but that falls into the same category of those algebra mistakes we make that, yeah, same category. Okay, moving along then. Maybe we'll have to do a little bit more than adding on this next one. A particle moves along the x-axis so that its position function is, these are hard to read today, x of t equals 2t to the third minus 9t squared plus 12t plus 1. That's your position. What are the positions of the particle at t equals 0 and t equals 3? What do I do to find the positions at time 0 and 3? You plug in 0 and 3, right? They gave us the position function, and we're trying to find the positions at 0 and 3.
I'll do 0, Trevor can do 3. Darn it.
I was going to do 0.
So I'm trying to find x of 0 and x of 3. Daryl just claimed 0 and is forcing Trevor to do 3. So
Use the calculator so I don't make any silly mistakes.
okay, so we know 0 is
1.
1. That's an easy one. 3. That's going to be 3 to the third, which is 27. Times 2 is 54. Minus 3 squared is 9. Times 9 is 81. So now I'm going to be at 54 minus 81 plus 36 plus 1. I lost track.
I got 10.
You got 10? Well, if I want to take the cheater answer, I'm going to say that's what my notes say. Okay, so those are the positions, right? Starting at 1, ending at 10. Who knows where all it went in between? But that's the beginning and ending positions. Okay. What is the total distance the particle travels between t equals 0 and t equals 3? I kind of just talked about this. Is it just 10? Or excuse me, 9? No, we're going to assume that they may have started at 1, but then there was some left-right movement, and they didn't just inch their way over towards 10. So, Thoughts on how we can find that total distance?
Are we going to have to take the integral?
We are going to have to take the integral. Because in order to find that total distance, remember velocity, definition of the integral of the velocity is, the particle moving along the x-axis, and it represents our sum. So, wait a minute. We're not taking the integral. What are we given? We're given position. How do I find velocity? Derivative of position. So we're not doing the integral right now. Okay. We've got to, on this problem, we've got to get to the velocity function. So we can look at that. Sorry, I fell for it and went right along with you down the wrong path. So because we're looking at total distance, we need to talk velocity. In order to do velocity, we need to do the derivative of position. Are we all there together? Sorry. My bad. So, what is velocity? What is the derivative of position? Six t squared minus 18t plus 12. Now think through this. We know that we started a position of 1, we ended a position of 10. How are we going to figure out when this, how we get from 1 to 10? Which way we're moving, when we stop and turn and go the other way. How are we going to figure that out?
Find out when velocity equals 0.
You got it. We need to figure out when velocity equals 0. Which means I'm taking this function we just found and setting it equal to 0.
And then divided by 6.
Right. Well, and that's what I would go ahead and, whether you factor out the 6 or divide by 6, I was just getting ready to say let's factor out the 6. Daryl says let's divide it out. Same idea, right? So 6, if I factor it out or divide it out, it's going to be t squared minus 3t plus 2. And because we just set it equal to 0, yes, you can divide the 6. It's gone. No worries. What do you know about t squared minus 3t plus 2? Factors.
T minus 2, T minus 1.
T squared is t and t. T minus 2. T minus 1. Not what I meant when I said t and t. But sure, dynamite. So what are my t values here?
2 and 1.
Yeah, set each part equal to 0, and my t values are 2 and 1. So what are those values?
That's where it's changing direction.
It's when it's changing direction, okay? Or when it's stopping at least, right? So we need to look at, we already know the position at time 0. We already know the position at time 3. We also need to figure out the position at times 1 and 2. Does that make sense? So if I go over here and write these out, I already know x of 0 was 1. We found that out earlier. I'm also going to need to know x of 1, x of 2. I'm running out of room, and I didn't want to run out of room. And then x of 3 we already knew to be 10. I was trying to space those out so I could show the distance between them, but okay. And again, this is when the particle turns, or at least stops, right? At x of 0 is at position 1. What about x of 1? Take the 1, plug it back in up there. And plug in x of 1, we get 6. When we plug in 2 to our position function, 16 minus 36 plus 24 plus 1. Thought it was just 5.
And maybe, I don't know. Them signs are always confusing.
16 minus 36 takes me a negative 20, but then plus 24 takes me a positive 4, plus 1 is 5. Okay, so total distance. How far did it travel from time 0 to time 1? How far did that particle travel? Started position 1, went to position 6, so it traveled 5 units. What about from time 1 to time 2? How far did we travel? Okay. We traveled left 1, yes? What is the distance there?
It would just be 1 because total distance.
Okay, and this is where we have to be very careful. Because they're asking total distance, does that 1 that they went left, is that still part of counting? Like if you're counting, if you're watching the miles on your miles on your cow? Wow. Miles on your car, if you're counting your steps. Just because you went left or backwards, it still counts, right?
Unless it's Ferris Bueller.
Unless, of course, it is Ferris Bueller's Day Off and you are trying to run, was it Daddy's Porsche?
I think it was a Ferrari.
Ferrari, whatever Daddy's car was that you're trying to run the mileage bag. Okay, Ferrari is what it was just confirmed as. I haven't seen that movie in years, but I just remember it being some fancy car.
I haven't ever seen it.
You just know the story.
Yeah, I read about this car because the car had a 302 Ford in it with a C4 automatic. And it was a fiberglass body, so that way it wouldn't be. So it was a whole lot cheaper than the real example would have been.
Leave it to Daryl
And they had like
to have not seen the movie but know all about the car. Okay. And from time 2 to time 3, traveled 5 units, right? So if this is total distance, then we're adding all the positive versions.
It's supposed to look like a stick shift, but if you watch the movie closely, there'll be times they have like both hands in the air and the car is shifting. Because it wasn't a stick shift. Because he didn't know how to drive a stick shift.
Okay, 5 plus 1 plus 5 is 11. Learn something new every day here.
I have to watch that movie again because I didn't notice that the first time I watched it.
You were probably a lot younger when you first watched it.
Yeah.
Okay, example 3 if you guys are ready. The acceleration of a particle on the x-axis is a of t equals 4 pi cosine of t. If the velocity is 1 at t equals 0, what is the average velocity of the particle over the interval 0 to pi? So they give us acceleration. Velocity is 1 at t equals 0. So what I tend to write here, just so I have it in writing, is that v of 0 is equal to 1. Because I said the velocity at time 0 is 1. The question is asking for average velocity of the particle over the interval 0 to pi. Well, thoughts here?
If we're using a calculator, it's probably going to be in radians.
At least we got pi in on today. We took that celebration.
Yeah.
Oh, there we go. We get to talk about pi on our Pi Day, one day late. Okay, so they gave us an acceleration formula, yes? But they're asking us questions about velocity. So what are we going to have to start by doing?
Integrate acceleration.
Yeah, in order to find velocity, velocity is the integral of acceleration. So we're going to integrate 4 pi cosine t dt.
4 pi stays the same.
4 pi is 4 pi. What's the integral of cosine? So 4 pi sine t plus c. How do we find c?
V of 0 has to equal 1.
Yeah, v of 0 is 1. So plug in 0. 4 pi sine of 0 plus c equals 1. We know the sine of 0 is 0. So that means we just learned that c equals 1. So my velocity function, v of t, is 4 pi sine t plus 1. Okay. Got a velocity function. How do I find average velocity over the interval 0 to pi?
Do we just plug in pi into the function, then divide by pi?
No.
Is that 1 over b minus a, and then from a to b of something or another?
Okay. So, average velocity. I tried to tell you guys last week when we talked about the, I'm trying to think, was that just on Friday or was it? It was on Friday. Average value of a function. When you see the word average value in a question, it's basically the integral from a to b, but then you have to put a 1 over b minus a out front. So, what are my a and b values here?
Pi of 0.
Yeah, that's that pi and 0 there. So we're going to go, in order to do average velocity, 1 over b minus a, so pi minus 0, times the integral from 0 to pi. And if we're trying to find the average velocity, we're going to use our velocity function. So the integral of 4 pi sine t plus 1 dt. Out front, we basically have 1 over pi. Well, you can only pull a 4 pi out of the first term, though. So we can't, totally factor it out. Yeah, there is a plus 1 there. That plus 1 is going to matter. We're not doing the derivative. We're doing the integral.
It was a simple problem.
Okay, what is the integral? And on the 4 pi sine t, okay, just think. I know it's going to have 4 pi. What's the integral of sine of t? Negative cosine of t. So basically this becomes negative 4 pi cosine t, if you will. Plus, what's the integral of 1? t evaluated between 0 and pi. Again, I'm keeping that 1 over pi out front. First of all, I'm going to plug in pi, right? So negative 4 pi times, what's cosine of pi? Negative 1. Then plus t, so I'm going to say plus pi. That's plugging in pi minus, and then start another parentheses, negative 4 pi times cosine of 0. What's cosine at 0? Positive 1. And then plus 0. In my parentheses, in my bracket, I still have 1 over pi out front. Here I end up with negative 4 pi times negative 1, so 4 pi plus pi, which is 5 pi, minus negative 4 pi times 1 is going to be minus 4 pi. So 5 pi minus negative 4 pi. So we're going to have 1 over pi times 9 pi, which just becomes 9.
Does it actually work that way, or is it just a coincidence that I forgot the 1 and I got 8 when I integrated it? As if I would have just waited till the last step and then just added 1, I would have ended up with 9 anyway.
It depends. It would depend on the problem. I mean, for instance,
Coincidence.
it's because my boundaries are 1 pi and 0. Like if this boundary had been something other than 0, that could make a difference. And just, if this had been something, it has to do with plugging in those boundaries because you would have plugged in pi right here and 0 right here. So if you were plugging in other numbers there, it could have made the difference. Does that make sense? Okay. And it is 9. They didn't give us any labels, did they? I had units per second written on my paper. I don't even see where they mentioned seconds, though.
So it could just be units per unit.
Well, or units per time is what I would tend to say. I don't know if I just assumed seconds, because I don't see seconds listed. Okay. Moving along when you guys are ready. The velocity function for a particle moving along the x-axis is given by v of t equals 2 pi cosine pi t. For what values of t between 0 and 2 is the particle stationary? So notice they give me a velocity function. V of t equals 2 pi cosine of pi t. And they want to know for what values, when t is between 0 and 2, is the particle stationary. Okay. Particle is stationary when the velocity is equal to 0. So that means I'm going to take this equation and set it equal to 0. So 2 pi cosine of pi t equals 0. We can divide the 2 pi out just for, confusion's sake. So really we're talking about when does cosine of pi t equal 0. Now, realize if you recall from, we did something like this in pre-cal, I believe it was, that pi t kind of throws things off, doesn't it?
It'd be whenever pi t is equal to pi over 2.
So start by asking yourself, if we forget pi t for a moment, you first have to be able to answer the question of where does just regular cosine equal 0, right? If it's just cosine of x or theta or, when does cosine equal 0? So where does cosine equal 0?
Pi over 2 and pi over 2, but with our interval it knocks out the 3 pi over 2.
Hold that thought. So we know cosine equals 0 at pi over 2. We know cosine equals 0 at 3 pi over 2. Technically, we could keep going, yes? Hang with me for a moment. What's another one? Five pi over 2? I just want to, we can keep going as far as we need to, right? Now, Daryl commented for what values of t is the part, and he's talking about that 3 pi over 2 is out of that. We don't know what t is yet, though. So we want to think about several intervals, and we can even go more if we need to. Because we're not just setting, this wasn't just t equals these values. What was in here that we have to use? In this particular problem was pi t. So we're taking that pi t and setting it equal to each place that cosine equals 0. Because in this problem, it wasn't just the variable in there. So if I say pi t equals pi over 2, what happens when we solve that for t? You divide by pi, the pi will cancel, and you'll get t is 1/2. Is that in the interval? Does this point matter? Yeah, it's from when time is between 0 and 2. 1/2 is a valid option. What about pi t equals 3 pi over 2? Divide by pi, and t is 3/2. Does 3/2 matter? Yeah, that's 1.5. That's in the interval between 0 and 2. Okay. What about pi t equals 5 pi over 2? Divide by pi, and t is 5/2. Do we need that answer? No, because it's 2.5, it is now past the interval of 0 to 2. And so obviously if this one had stayed in the interval somehow, then I would want to keep going and, until I find one that doesn't work.
That was half right. I just cut the 1 too soon.
Yep. Which is why I notice I even went 1 too far on purpose. So, if you have questions, let me know. Otherwise, we still have one problem on the back side. I guess we got a slow start today, didn't we? I was like, I didn't feel like this lesson was that long.
We did eat high.
Lost my problem. There it is. Okay. What is the total distance traveled to the left by the particle in example 90.4 between times t equals 0 and t equals 2? Which, if I recall, that's the problem we just did, right?
I felt like we only half did that problem.
Like you felt like there should be another part B coming up here?
Yeah, I felt like we only did half of the problem for 1 equals 4.
Well, here's the other half. So, okay. Total distance. Specifically traveled to the left by the particle in example 90.4 between the times t equals 0 and t equals 2. And if you recall from the front side, the problem was v of t equals 2 pi cosine of pi t.
That's a nice color for Mark.
Did I save it? I don't think I did. Okay. What do we need to consider here?
We need to plug in 1/2, 3/2, 0, and 2.
Okay. So Daryl says we need to plug in 1/2, 3/2, 0, and 2, and how's that going to help us?
It'll give us some numbers, like on the boundaries, and then we can figure out which one is moving left and
Okay. When is a particle going to be moving left?
what velocity is negative.
When velocity is negative. And if you look at a graph of velocity, when is velocity negative? Or how do we know based on looking at a graph? Below the x-axis. So what if I look at a graph rather than and again, remember, we only need 0 to 2. Now, I don't know if you guys figured out what I was doing earlier, but notice if you go back to the previous page, at pi over 2, it was at 1/2, right? At 3 pi over 2, it was at 3/2. And I think you could graph this on the calculator and that would work for you as well. But basically what you're looking at is a cosine curve, guys. Oh, I didn't change. The 2 pi out front makes it a very stretched cosine curve if you see mine. Now, I only need to know, though, I forgot to change, from 0 to 2. If I change that from 0 to 2, notice, what do we have here? A big old cosine curve. Okay, so from 0 to 2, we have a big old cosine curve happening. And if that's from 0 to 2, and this is just a regular curve, then we already know these intersection points here are at 1/2 and 3/2, because that on the previous page was where our velocity equaled 0. So those are our zeros. When I just asked a moment ago, when is the velocity traveling left? I was told that it travels left when the velocity is negative. And so where is this velocity negative here? Yeah, between 1/2 to 3/2. Now, so we know that the velocity is negative between 1/2 and 3/2. Do we know the distance traveled? Not yet. How are we going to find it? Not going to plug them in. We're going to do the integral from 1/2 to 3/2 because we're trying to find that elapsed distance there. So the integral from 1/2 to 3/2 of 2 pi cosine pi t dt. Yeah, you can think about the 2 pi separately. What's the integral of cosine of pi t? Sine of pi t. Times 1 over pi. Because that's not a number out front. A normal number, like a constant. Pi is a constant. I'm saying this all wrong. It's not a normal, like, whole number, like we're used to. But pi is a number, and so you have to compensate for the chain rule, so 1 over pi. Evaluated from 1/2 to 3/2. Again, I'm keeping my 2 pi out front. Actually, what could I do instead of, well, I said keeping my 2 pi out front. I can also keep my 1 over pi out front, couldn't I? And then all you're really plugging in, so it's sine of 3 pi over 2 minus sine of 1 pi over 2. What happens with the pi's out front? They cancel. Sine of pi over 2 should be -1 minus sine of pi over 2 is 1. -1 minus 1 is -2 times 2 is -4. What's the negative mean? Okay, it was all traveled left. So negative sign indicates area is below the x-axis. So particle moved 4 units left. Okay. So negative sign indicates the area is below the x-axis, so the particle moved 4 units left.
Are those equivalent answers, -4 and 4 units left?
Yes. Okay, and you can't see what I wrote, I just realized. Substitutions, 22 through 25 are 5 through 8 from 86. 16 becomes 23 from 87. Okay. You guys had a homework due today, didn't you?
Yeah.
Well, I guess it doesn't take but a moment for me to glance at 2 people's homework, but Nathan and Logan, you guys can email those to me when you get a chance.
That's why Trevor didn't risk it. The whole email thing.
And plus, I'm just antisocial in general. So.
I don't know. Logan tends to have trouble getting stuff to me via email, so who knows when I'll get his. I might get him months later.
Like how you just finally got my emails that I sent, like a couple of months back into school.
So, I guess my plan this week is supposed to be 90 today, 91 tomorrow, 92 Wednesday, review Thursday, test Friday. Is supposed to be our plan this week. So now I have to figure out what I want to do about the test on Friday.
Every minute you threw me. And now you're like, today's supposed to be 90 tomorrow. I'm like, what weather are you looking at?
The weather today?
Yeah, when you're up there, you're like, here's what I got. Today's supposed to be 90, tomorrow 91. And I'm like,
Oh, you thought I was talking about the
what
weather?
weather are you looking at?
I guess I'm looking at July's weather. If we're talking 90 degrees, yeah, definitely not. Now, when is your guys' play?
I got moved to like April 9th, 10th, and 11th.
This coming weekend is when it was supposed to be?
Yep.
Wow. I gotta love it. Gotta love it. So all that. At least hopefully you'll still get to have it. Unlike last year at this time when, you know. You have plenty of time this week while you are quarantined to work on your lines, right?